am Mithra, this is my partner Kruthi. Today our project is about fluorine, which is the exceptional halogen, and we have analyzed this based on the Lothar Meyer curves, which is this one.
The Lothar Meyer curve generally shows the relationship between atomic mass and atomic volume. And it helps scientists understand that the properties of elements repeat periodically. The halogens chlorine, bromine, iodine and fluorine usually have an increasing atomic volume as we move down the group.
But fluorine is an exception because although it belongs to the halogen family, its properties are very different from the others. Let's take a look at this unusual behavior of fluorine. It is the most electronegative element present in the periodic table, meaning it attracts more electrons than any other element. You can see here the jump between iodine and fluorine, and also the difference between chlorine and fluorine itself. Fluorine stands at almost 4 electronegativity. And this is what makes fluorine so chemically unique.
Unlike fluorine, bromine and iodine, fluorine only shows -1 oxidation state. And also its extremely small atomic size contributes to its unusual behavior.
And because of these unique properties, fluorine is much more reactive and it behaves differently from the other halogens. Fluorine forms a covalent bond, but contrary to expectations, this bond is very weak due to its small size and high electronegativity. The electron pairs repel each other very strongly. This is an overview of all the anomalous properties shown by fluorine. We have seen electronegativity. Fluorine has the highest, while other halogens show very low electronegativity.
Helps us understand the periodic table. Fluorine stands as an exceptional. And
Now let's check what we've learned during this presentation.
So may I ask you some questions from what you learned, children? Yes, sir. So why they told that the fluorine is exception from Lothar Meyer curve? Because it has very low. Because of very low atomic volume, it shows what, children? Anomalous properties. Will you show that? Will you show the graphical representation? Yes. So where is the atomic volume of fluorine, children? Atomic volume of fluorine is comparatively less than remaining halogen. So because of its very less atomic volume, what happens to its electronegativity, children? It is very high or low? Very high. May I know why it is very high compared to remaining halogens? Because of small atomic volume. Okay. And that is the electronegativity. And may I know, as the students told this has a -1 oxidation state only. Fluorine never shows +1 oxidation state. May I know what is the reason? Because of high electronegativity. What was the next point you discussed? Yeah. Can you tell me why the fluorine-fluorine bond is very weak? Because of repulsions between? Why the lone pair repulsions are there? Because of? They come close to? So because of the repulsion, fluorine-fluorine bond is very weak. What was the next point you learned? So they are telling that hydrogen fluoride is the weakest acid. May I know why? Strongest bond, weakest acid. So finally conclusion is, so why the fluorine is showing anomalous properties, children? Because of its small size and atomic volume. Okay. Thank you, Sri Mitra, and thank you, Kruthi.